So I'm very glad to introduce you Eduards Sizovs. He now have his talk, and if you are very interested on it, you can continue in his workshop or just how you tell it.
Yeah, okay. So guys, nice to meet you here. And let me start with a small secret I would like to share with you. Basically, I asked organizers to put my speech before lunch because I'm interested in stealing 10 minutes of your lunchtime. That's a big secret. So that's up to you, stay or not, but it's a special time for questions. So 30 minutes for this talk is not enough. Okay, I'm Edward. I work as a chief software architect in a company called For Finance in Latvia. We have offices in Vilnius and in Estonia as well. And we're building quite complex micro-lending platform. And on top of this platform, we build a lot of projects around the world. So in Lithuania, you might probably heard about Vivus LT, SMS Credit LT, but you are not our target audience. Okay. So this is a so basically the agenda is as the following. So we will talk about code structural analysis. So I will introduce you what is this structural analysis about, and we will talk about logical design principles that forms this theoretical basis behind code structural analysis. And we will have a time for questions and answers. And basically we will continue with a more practical presentation after this speech. So, let's start. Basically, when you start develop application, you keep everything in mind. You have a small application, really well designed, and within your team you can collaborate all the constraints, maybe some layering, and you have just a 10 or I don't know 15 packages. Wow! But you can keep it in mind. You don't need some special tool sets or some special knowledge to manage it. So everything is fine, application is really sexy. Time goes by, we have requirement rain, a lot of changes coming from the outside. Hey guys, do this, do that, changes, just a lot of requirements, maybe weird requirements as well. And if you are not taking into account being a coding monkey, you're just exploding your app. But time goes by, you're quite conscious about design, you introduce some changes, everything goes well, seems like. At the end, for some reasons, you end up with some rotten enterprise app, so just a crap. And so something goes wrong, but our designs start to rot. And we feel that. We can't understand it, we can't visualize it. For some reasons, developers start to leave your project for some blue chip area, so just they are not interested in working in this mess. Something goes wrong, you slow down, but you can't understand what happened. And we feel a lot of symptoms, kind of. So someone feels that it's really hard to change design, it becomes immobile. So you drag some part of your software, it impacts different other parts. Or employing kind of really good solution is harder than introducing a workaround. All we know that, right? So needless repetition maybe says that, for example, in different places of your system, there's the same concept represented, but in a bit different forms. So a lot of stuff, and that makes you slower, but you can't see that, so you feel that, and developers live in. Okay. And without particular practices, without tool set, you can't fix something you can't see, right? And what structural analysis shows, basically, is this. This is a quite interesting picture. That is a structure, a logical structure of Hibernate. So who knows what's Hibernate? Are the Java developers here? Nice. So guys, you probably know that no major changes have happened in Hibernate since maybe 5 years, so almost the same framework, but it's really hard to evolve. So that's called big ball of mud. We don't see a structure. It's just any-to-any relationships, and everything can talk to everything. And there are no guidelines for developers how these functional parts are related. In order to introduce some new functionality, you have to understand this big ball of mud, this picture. And the problem is when you introduce some conceptual changes, you don't understand where to put it. And even if you produce some localized good design, it will be eaten by this big ball of mud anyway. No way, right? That's how Hibernate looks like, and it's still the same, by the way. If you try to introduce some commit or just create some pull request to Hibernate, you know what I'm talking about. They just say, no, you can't change this Hibernate framework. Okay, and it's artwork by Jason Pollock, and you feel this similarity, quite the same. It's art, but what we developers produce, we produce crap. However, it could be better. It could be just, some people say, this lost minds say that hey guys, everyone, we can't create application that can evolve in a quite solid way, so at the end we'll end up with the crap. Don't believe these guys, it can be different. For example, that's a structure of a Spring framework. We know success of Spring framework, 10 years or even more, successful evolution without breaking changes. Internal stuff just changes, all this annotation, configuration appears, so a lot of stuff, and they started to produce even more software on top of Spring data and a lot of stuff around. So someone that took care about the logical design, you see, there's some high-level blocks, low-level blocks, and there are some arrows, and there is some meaning behind these arrows, except one red arrow. Don't take a look, but it's better than Hibernate, right? I would prefer work in Spring framework. As a new developer, I would join this team, would try to understand the structure and where to put particular stuff. It's basically documentation of your design. It's your architecture. What architecture? What is the architecture? It's a structure. Quite simple, right? So, what is structural analysis? So, structural analysis allows you to keep your application in shape, under requirements reign, and catch design flows early. So you can introduce a process of structural analysis in your development phase. You can just change something, take a look, change something, take a look, change something, take a look, and you can visualize what you have. And let's start with some theory behind it. Logical design principles. Ta-da! So first of all, we have to understand that package in your software is something really important. It's a base element of your logical design. It has some meaning. It's not just a container where you put some classes and just nothing. It has a meaning. It's a base element of your design. Package represents a concept, some particular functionality. It should have some responsibility, ideally only one responsibility, right? So it's a key element. Treat packages as a first-class citizen in your design. And what's important, even if in your development environments, Eclipses, IntelliJ, packages are represented as a flat, they're still hierarchical. There's a hierarchy in your packaging system. What does it mean, for example? If you'll take a look at this really simple example, we'll see that there's a package called client. And inside the client, there is a personal package and profile subpackage. Okay, cool. But the thing is that usually developers don't understand the difference between just going deeper and going just in a vertical direction, meaning that when you dive deeper into this packaging hierarchy, it becomes a part of something. So personal and profile packages are part of client. And being related to something does not mean it should be a part of something. So for example, in this case, we can afford basically that personal, profile, and client packages are really tightly coupled, that can be related. That's a part of. Yeah? They can be related, they can be tightly coupled. For example, in domain-driven design, this client could be an aggregate root for a personal and profile aggregates or some composable classes. Yeah? There is some kind of scope, and for example, talking about client and API relationships, they should be somehow less coupled, because API is not part of a client. They are just somehow related. Maybe API uses client, but it's not part of. That's really important to understand. You can just to take your application into account, just take a look at that and ask yourself whether a particular package is part of some higher level package. Most packages will not be compliant with this rule. You have probably seen the packaging system where just some package dot impl, right? A lot of people do that. What the fuck? By the way, how implementation can be part of particular abstract concept, for example? Sometimes it's weird. Okay. About grouping. We have to package our components, artifacts, according to some functional criteria. It's about logical cohesion and kind of functional cohesion. Yeah, because you have seen probably layering than just you have DAOs or services and domain, helpers, utils, some other functions just separated, yeah? And inside you break them according to functionality. That's weird, because these stuff are kind of similar, but they're different by nature. So for example, take a look at this small example. So this is a kind of logically cohesive layering. This is a functional one. So you put everything related to kind of client together. It's kind of repositories, some domain services maybe, entities, value objects, whatever. The idea, it's not about kind of layer first or a level first design. It's about putting artifacts that are tightly related together. Because do you really believe that kind of you will receive a user story, for example, hey guys, just go and change all the repositories? No, you'll be asked to change, for example, some client-related functionality or landing or loyalty. So you end up with a better design with a collocated change. Just change here and build an API around. So it's kind of a domain-driven design. Layering is preferred. It's kind of DDD packaging. That's an interesting one. And how we can understand this kind of what functional parts of your application are represented in your application if you have this logical layering. You can't. And what are the relationships between them? And for example, if you'll end up with some re-architecture, hey guys, let's just extract landing to a separate module. Wow, you'll have to go through all these packages to collect it back together and extract it to some systems. That will be crazy. In this case, you understand that all the client landing-related functionalities grouped together. Makes sense? It makes. Okay. So we have to group tightly related artifacts. It's not about classes, by the way. It's always about packages as well. We have to group tightly related stuff together because we are interested in localized changes. You're interested in just a change in something here. You don't want to go here, change it here. It's kind of shotgun changes. Change it here, change it here. Collocated changes are preferable, right? So, and it's really important because if you have a lot of packages, a lot of modules, you'll just go through everything to introduce some changes. And it's about kind of developer work, parallelization as well. You want one developer work on a particular concept, another one to a separate concept. A lot of stuff surrounding it. So don't go for shotgun surgery. Strive for collocated changes, localized. Whoa, whoa, whoa. Okay, you collocated your functionality together. Everything works pretty well. But then new developer arrived, joined your team, and started just changing your code. Cool. And you'll end up some broken design maybe if you're not enforcing this kind of collocation. You have to guarantee that your artifacts are not floating away. Right? Because if the artifact, that's kind of, I have a concept, and there's a class which represented that concept. Some developers came, introduced a new title-related concept, and put it some external package. Okay, and then new developer come and base their assumptions on that decision as well. So design start to evolve in the wrong direction. What's important, you have to restrict the kind of these dependencies by using a particular tool set. I will show you later what tool sets you should use. It's really important. Just enforce these dependencies. It's kind of extra work, of course, but it's really important. Okay, let's go. my presentation doesn't work anymore. Again, the same problem like before. Let me give it a try to fix it. Hey, you gave me a broken PC because yeah. It just doesn't, okay. Aha, this one is quite interesting. You have to strive to make your packages cohesive, really cohesive. And they should follow single responsibility principles as well. So it means that if you think deeper, it's more preferred to have a lot of small cohesive packages instead of some big packages in your system, because you lose this flexibility in defining dependencies, right? You have two big packages, it either goes here or there, or you have a lot of small packages, this package can talk to this package, and so on and so on. So you will have a kind of fine granularity. So it's the same like with the class, a single responsibility principle, yeah? It works on packages as well. There should be one reason to change for a package. It should represent a particular concept and do one thing, but do it well. Right, yeah? Cool, that's clear. And this one is interesting as well. So classes these artifacts or packages should be loosely coupled. What does it mean to be loosely coupled? Maybe completely independent, yeah? And I saw a lot of examples when people try to decouple packages by using reflection. It's even worse than being directly dependent on a particular class, because you can't catch these refactoring changes earlier. So what's the benefit? You gain portability. You produce a really portable design in this case. Small packages, no one depends on them, and it does not depend on many. So it's a kind of afferent and efferent coupling is low, right? You just take your package, no one cares about this package. Just throw it out to a separate physical module, or create a system, or move it somewhere. So you are flexible. You can move these parts and don't care about the kind of consequences, I would say. And but how? How can it be done? So of course, interfaces, some abstract factories, a lot of stuff, sure. But let's take a look on a small practical example. So guys, there's the two packages, loan and client. Only two classes, loan and client. Cool. And then we wanted to create a relationship. So basically, loan depends on the client. So we map this many to one, maybe, okay. Cool, everyone does it. Really? That's just common case, really quick solution, bam. But guys, now we just connected two concepts. So we connected deeply loan with the client. And I, as a new developer, I can use a lot of client stuff within a loan, right? Okay, I can call a lot of stuff and just, cool, I can break your initial idea. So no one forced you to go to a client and call all these public methods, for example. Quite interesting, but it's a well-known anti-pattern of aggregate design, by the way. There's a potential solution. What if we design this relationship this way, for example? We created some small embeddable classes, a class called client ID, and put a long here. And just made it this way. Yeah, you lose this eager, lazy loading for hybrid, but who cares, yeah? For example, NoSQL database will push you somehow to use this design usually. That's okay, but you might probably, so there's a decoupling between these two concepts. But why I have wrapped this client ID into long, why I have wrapped long value? Because still, if I just put my code in the code structural analysis tool, I want to see this loan is still loan still depends on client. You know, there's a kind of explicit relationship. So I want client ID to be held in the same packages as a client, right? So there is dependency between concepts, but concepts are really decoupled. Make sense? Right. But package interface. So just if we treat packages just a container for everything, we forget about basically about interface of a package. So there's a package, a lot of class here, and everyone can use classes inside your packages, right? So, but package should have a kind of slim interface, ideally. And all these implementation details should be hidden. So what can we do? So for example, if we use some Spring maybe. By the way, do you know that you can make your kind of components package private? You don't have to expose it. That's a good way of hiding implementation details. Just make an interface public, hide implementation, make it package private. Cool, one approach. So factories, service locators, a lot of stuff. So kind of the rule is be conservative in what you expose, because yeah, just everything that is visible can be used, right? Why not to use this particular class somewhere else or reuse it? There can be broken reuse as well. Or for example, in many frameworks, we see that kind of internals are extracted in a separate internal package. So just some packages, and there's a package internal. So they put a lot of stuff inside. So that's one of the approaches how it can be managed in Java. But the interesting fact is that you have an API, for example, and you have internal stuff. And you have to make sure that an API is not dependent on internal stuff. In this case, you'll lose portability. So in order to drag your API out of this package, you will have to take care about the internals as well. Still, this dependency makes sense. So you'll have to make sure that internals are dependent on the API. It's kind of interesting. It's called dependency inversion. I will talk about it later. Let's go. And here's a buzzword in your toolbox. When you do a code review, you just can kill your fellow colleague with this word. So connescence. It's kind of interesting form of coupling. So two components are connescent when, in order to maintain overall consistency of the system, when you change one component, you'll have to change another one. Kind of a coupling, yeah? So there are different forms of connescence. For example, connescence by name, connescence by order, for example. So, and the weakest form of connescence is preferred, because it's a lower coupling, basically, we can say. So, for example, your two components agreed that arguments should be passed in a particular order. That's kind of strong form of connescence, because if the order of arguments change, you will impact the client, yeah? So, for example, connescence of name is better in this case. You agreed on a name of a concept. So, and what's important, you have to keep locality in mind, meaning that connescence and kind of coupling, they are unavoidable in your design. You can't design your system when everything is isolated. There could be some decoupling or some, but still, components collaborate somehow. And locality is important stuff. So basically, it says that the more close these two components, for example, locate, for example, remember this first example, client and internal packages. So we can kind of afford strong connescence between these elements. But going down, for example, if you take a look on your architecture about this related concept, so connescence should be lower, right? So it's a collocate change as well. That's about connescence. So you don't want to impact API, yeah? For example, because it's really far from you, from your packages. Let's go. This one is really practical. Dependency magnets. Dependency magnets are kind of classes or packages that are actively reused by someone. But everyone was taught to reuse code in the universities by some mentors. Maybe reuse. Don't repeat yourself, right? But reuse has a great limitation. It makes your design not portable again. You depend on particular thing, and if a lot of stuff depend on this thing, and you can move this particular thing because it will impact a lot of clients, a lot of packages maybe. So sometimes duplication is not that evil. For example, in Spring Framework, yeah, they have a lot of utilities, for example, a lot of util packages, and they just duplicate utilities because they want to gain flexibility. Because sometimes, so you have a kind of utilities package, but different parts of the system requires a bit different utilities, usually. Different way how to use these utilities, and people just put everything inside this common package, and you take a look, just something weird here. So it's about dependency magnets and how it can be solved. So basically, for example, usually in different system, kind of business systems, you have a client entity. Everything is related to client. Some lending process, payment process, client, 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 client. And you just take your client entity and pass it everywhere. So every parts are related to your client. But the interesting fact that usually in the system, there's a kind of there's a client, but it has different forms, so kind of facets. So when user, for example, when client is not registered in your system, it's a guest. However, it's client, but in future it will be client, so it's a guest, one concept, and pass this, for example, guest, and you have a client, and when client, for example, applies for a loan, it's in our context, he becomes a borrower. So basically, it's still the client, but there are 3 entities can be designed out of this client. That's good, and you just pass borrower to context responsible for borrowing, for lending, kind of client to client, for work with the registered user, and guest to a kind of a registration or this process. So great decoupling, and it's really hard to just find these solutions, and that's why you have to understand your domain as well. And yeah, of course, client can be broken in different parts. As I said before, if you have some, I don't know, concepts related to client, it's not necessary to put everything inside. Some architectures force you to put everything to a client because, for example, on a user interface, it's easily to report from a client this way. It's kind of weird because these kind of architectures are quite interesting. Maybe you can apply CQRS patterns in this case, something like that. Okay. Remember these arrows? So I showed you Hibernate and Spring, a lot of arrows around, and the first picture was a big ball of mud, and this one kind of, and Spring was quite clever, academically sexy design, it's called. So, and all these arrows between packages should have a meaning. Concept, business concept, another business concept. There is some logical dependency between concepts. But usually we don't care about it. Just put here and there, and just all these arrows start to appear, and we end up with some bidirectional dependencies between packages. Okay, but it works. But just, it's hard to reason about your design. It's hard to understand, basically, and you cannot levelize your architecture, by the way. That's a really important concept in software architecture, is levelization. You can't levelize cyclic packages. So, okay, so I propose you to burn bidirectional dependencies in fire. So every dependency should have a direction. So 2 packages, it's either this direction or opposite direction. No bidirectional dependencies, because if there's a bidirectional dependencies, probably it represents one concept, or it's a wrong design. Otherwise, here's a structure of a find box. Everyone knows find box, a great tool for finding bugs. Okay, so that's how find box started. Clever design. I don't know, for about 10 packages, everything is managed, clear arrows, and everything okay. Then someone just introduced bidirectional dependency. So good design, but now it's imperfect, but quite good. And then someone added more problems to that design, so kind of imperfection takes hold. Now, in order to fix this design, you should spend some reasonable amount of time, but it works. And then here, version 1.3, chaos begins. What there? Crazy. And boom, you end up with explosion. That's one of the latest versions of findbox. Yeah, I don't want to contribute to findbox because it's really hard to understand where I should put the code. A bit crazy. So that's now how it looks like. Because, by the way, almost dead project. So the conclusion is that dependencies between packages must not form cycles. So either here or the opposite direction. Cool. There are different practices. How can these cyclic dependencies be eliminated? How? And there are different practices. So first, let's start with the first one. It's a merging. You extracted too much. It's still a one concept. So sometimes there are such cases. So you extracted too much and just get it back. Just merge it back. For example, when you separated state and behavior, for example, just take them back together, merge. The easiest way, but usually not the best solution. The easiest, yeah, you might end up with one package in the system. Yeah, no circular dependencies. Cool. Shada. And there's a dependency inversion. So you see here's a guest package and tracking package, bidirectional dependencies. Business says, for example, that guest can live without guest tracking functionality, but tracking is really related to guests. So you can track you can track user if there's no user represented in your system. So we decided, hey guys, let's make this dependency, for example, from a tracking to guest and eliminate the wrong arrow. Do it this way. So I will not show you now how it can be done, but believe me, every arrow dependency can be inverted back. No exceptions, always. So that's a dependency inversion. Solution, great. But escalation, so one more pattern. We have a customer, we have bills, and in order to calculate discount, so basically customer responsible for discount calculation. It needs to know historical bills to calculate discount. Normal design, and there's a bill with method pay that takes customer as a parameter and asks customer to calculate discount and then process payments. Bidirectional dependency. Customer is here, it uses billing. Billing is here, it uses customer. Cool. How can it be solved? So, and we want, for example, in this hypothetical case, customer is dependent on billing. Let's eliminate this arrow, burn it in fire. Ta-da! That's called escalation. So you understand the root cause of the problem and put it to a higher level module. Just put it up. So there's a discount calculator was wrong. So we just introduced the concept discount calculators that depends on the customer and bills. Okay. For example, so it now depends on both packages. It goes up, really, it's high level module. And basically, a discount calculator is responsible for calculating, not the customer itself. And for a bill, we pass the result of calculation. So that's just kind of an academical example, quite easy, but that's called escalation. It's just to simplify it. Take a cause of a bidirectional dependency and move it up. Cool. Now we end up with a non-circular dependency, acyclic. Demotion. Take a cause of your dependency and push it down. So you introduce discount calculator, but now it does not accept customer and bill as a parameter. So just it's independent. It goes up, it goes down, sorry. And now customer can kind of return a discount calculator and ship all the information necessary to calculate discount inside this discount calculator instance. Cool. And there's a bill class that accepts discount calculator. Here it goes. Clear design, yeah? In this case. It might be wrong design, but I assume that the direction initially was chosen in the right way. So, that's it. That was one of the most complex parts. Okay, a bit about Solid. Just a couple of comments. So, basically, packages. So basically, these arrows between packages are made by classes inside the packages. Packages they are not dependent. Classes make up arrows. So, and if you will have a lot of big classes, it will make your design wrong by default. It will drive you towards all this circular design. So smaller packages, flexibility to package them independently, some interfaces, abstractions, you end up with a small concepts in the system. So basically solid rules apply on the logical design as well. And this is how dependency inversion works, really quickly. Official definition says, hey guys, depend on abstractions as anything concrete is volatile. Yes, it is, but who cares? Dependency inversion principle allows you to just invert arrows. Cool. Let's take a look on example. two packages, class X, class Y. Cool. So if class X depends on Y, there's a dependency between packages, right? Okay. Let's invert dependency for some reason. Cool. Let's take a look. X called something from a Y. I extract this method to an interface, extract it, and put it here to the opposite package. So you see that this Y implements this interface of this particular method, and X called this method through an interface, but dependency changes. So basically, the thing is that just extract an interface doesn't change anything. Just extract and put it here. Dependency is here. Extract and move to the opposite package. That's the essence of dependency inversion. It's really important. It works on the component design level, physical design level, between applications even. That's how it looks. I suggest you to learn this stuff, by the way. Yeah, and one more. So interface segregation principle. So the idea is that prefer a lot of small interfaces, kind of client-specific interfaces, instead of one big interface that represents everything in your system. Otherwise, as a client, I use this interface. This is big one, and I'm implicitly coupled on everything that is defined in this interface. That's crappy. So design small interfaces, put them in a separate packages. Cool. It will work. Okay, guys, just a couple of words about tooling. So remember I mentioned about this managed relationship, these arrows, how they can be managed. So first of all, Maker, classical, and JDepend. So you can define in particular format dependencies between packages and include it in the build time. So build will fail if there will be unexpected dependency between your logical artifacts. Quite easy. We use Maker in our systems. Classical and JDepend are quite good as well, but Maker is easier, I would say. Sonar. Everyone knows Sonar. But the problem with Sonar is that it's a kind of, you already introduced a violation. So you commit your code, and at the end you'll take a look on the Sonar, and yeah, the violation is here. I don't care about fixing it. But there are good patterns of using Sonar as well. By the way, for example, you can virtualize a Sonar instance, so just provision it automatically. So your centralized Sonar instance is provisioned the same way as your local instance, right? So just before committing code, run a Sonar locally. Just run your Sonar, check everything is okay, commit, and then the centralized Sonar instance will help you. But it's not that easy. Stand4G. I will show you Stand4G in the next session, how it works. And the thing is that Stand4G is really the best tool for structural analysis. So it's really kind of rapid. It's really flexible. So you can see the impact on your design immediately. You just change one line of code, press F5, and you see the violation. Or success. No violation, just press push. Woohoo, enjoy. Structure 101 and a Sonar graph. These tools are good, but when I take a look on them, I just remember WebSphere, all this enterprise stuff. They're good, but they're really complex. And they are good if you already have a legacy code base that have a lot of violations. So you can, in Structure 101 and in Sonar Graph, you can define ideal architecture of your system. And it will not allow to introduce more violations for your developers. That's cool, because usually we start working on the legacy code base or something like that. And developers in their development environment will see the evolution of your code. So are they working right or wrong? So that's quite a good. Rapid tool, really expensive. But for new code bases, I would suggest educating software developers to use Stand4G and do not allow violations by default. Because yeah, if you have a lot of red arrows, for example, a lot of circular dependencies, some stuff, bad code creeping in, it's really hard to start, because how can you say, hey guys, don't introduce more violations? Code is full of violations. I don't know. Okay, that's how it looks like. Some reading, must read. Java application architecture is about. It's about logical, physical design. It's about modularity. Must read. It's a last year book. It's quite new, but really good. Agile software development. By the way, clean code sucks comparing to this book. So they just, Robert Martin threw out a lot of important stuff from a clean code, but a lot of good stuff is still there. So it's an old book, but really great. And pragmatic programmers, some good ideas about this metrics and so on and so on. And some movies, some documents. I suggest watching my own movie, kind of presentation, Solid Principles. It's about class level architecture, so it's kind of it might be quite interesting for you. Okie dokie. So, conclusion. Before we switch to a practical part. So we know that every application requires structure, right? Because structure makes your architecture. What is architecture then, if it's not a structure? So lack of structure, lack of architecture. And you don't need to be a software architect to make it real. Just start doing it now. Care about these dependencies, layering, everything. So, but in order to maintain the overall kind of high quality of the design, you have to manage it somehow. So what I propose, to integrate code structural analysis in your development. Install particular code structural analysis tool, for example, like Stanford-G or something. Take a look on your code. Now, just throw your code in, take a look what's there. It will show some stupid violations maybe from the beginning, but if you'll dive deeper, you'll kind of understand about these conscious problems, because these tools are really reasonable. So take a look at the big picture, start managing complexity immediately, because at later stage, it's almost impossible to manage this big design. It's rather better just throw it out and rewrite, really, or live with a legacy, or unhappy developers, and prevent design entropy. I wish you beautiful architectures, especially logical architectures we were talking about, and thank you.
Thank you for Eduards. We have a small gift for you.
Thank you.
And as there is no time for questions now, feel free to catch him during the breaks.
We're hiring, by the way. We're hiring really actively, together with Allah.
So now downstairs the lunch will be full of arrows.